So yeah, let's go to questions, and let me see. It looks like Daniel had his hand raised. Daniel, I'll ask you to unmute. Okay, and go for it. Oh, and you know what? It looks maybe he's not there now. Okay, let me see. Let's see who's next. You know, I could almost pick on Will because I think Will was Gary. You were talking about Will's wire. Will, would you go?
Yeah, I called out your wire a couple of times, William. I hope you don't mind.
Yeah, here I'll do ask to unmute. Keep in mind that it's tomorrow morning Will's time. So.
He's still muted.
Well, actually, I'm not sure what to really say. It's a nice upgrade to the paper for sure. As far as the wire, yes, we have a new physicist in superconducting theory working with this from last month. So we're looking forward to getting his involvement in getting the numbers to you. So,
great, yeah. If you get good permittivity numbers, I would love to get them, William. There's two ways to boost the permittivity. One is the sleeving around your wire, which would be the closest from a field point of view, and probably the most effective way. The other is in the core of the donut, you know, so-called donut hole, where all those gravitomagnetic fields are coming together and strengthening it there as well. So we might be able to do a double whammy there with getting better permittivity out of your wire and better permittivity out of the core.
of course, yeah. So as far as our superconducting materials are concerned, we can produce them in quite a large amount. So that's not a problem.
Good deal. Other questions?
Yeah, you know, Jeremy Reese actually had a question. So let me, Will, if you're all set for now.
Well, actually, Todd made a statement on the chat. So I'd like for him to speak up about his
chat. Yeah, let me bring the chat up.
Let me see.
His comment. So.
Or I could just bring, I'll bring Todd in. Todd, let me see. Todd, do you want to go for it, sir? Todd might have stepped away. Will, could you kind of read what it was that caught your eye about that, or?
Well, he stated that GC was a square of 2. So
G squared, yeah.
That's
my hunch too. And so I can sharpen my pencil with that, you know, and look at that as a case. And I can say right now, it is measurable if that's the case. It should be measurable.
Awesome. Okay, let me go to Jeremy Reese next. Jeremy, he's had his hand up for a while. Sir, go for it.
Hey, Gary, great presentation. I just had a question about the nanowires. You already answered one of the questions about the, you know, adding a coating, of course. Then it gets into a manufacturing issue. You know, how do we make these things, or where do you buy these things? And then a labor intensive one of, you know, God, how many windings is this going to be? And how do you, you know, the time consuming of making that? Or
I can answer the second part. I'll leave it to William to answer the first part. The second part is I've spent inordinate numbers of hours looking at auto winding machines for motors, for electric motors, because electric motors have, you know, tens of thousands of windings in some cases. And so those are robotically built right now. And there's ways that the robots, you know, spin these things around and wind these windings. But it's fascinating to watch the manufacturing videos of winding these electric motors, because the technology for that is all right now living off in Hong Kong and Singapore and Japan, and we're not really tracking that technology like we should here in the States. The other great body of knowledge for winding materials is in the fabric manufacturers, which again is all gone offshore, almost all gone offshore. with a few notable exceptions. The people who make Kevlar are still here in the States. And I actually have talked to them about winding nanowire material, and they were very interested at the time, because at the time we were talking about SMES devices when I was working at Collins and United Technologies. So there is technology there to do high-speed winding, but you would definitely want robotic machines to do it. As of
And
the
then-
first part, can we get the material? That's really a question. And what's the timeline for generating, a couple kilometers of this material? I will leave that to William to answer.
Then I had a question from the live chat about what was the purpose of using nanowire, and why is it the number of turns? Is it the
It's
current density?
Yeah, it's the current density. It's so much better with the nanowire material. Just so much better, because you really want a lot of current density to get any measurable gravitomagnetic field strength.
Indeed. And then the other question, what was the manufacturer of? What are you going to make these things out of? What kind of metal would you use? And
Yeah, it's not metal. It's a superconductor. I believe they're carbon nanotubes. Is that right, William?
Actually, that's all proprietary information, and I can't comment on any of it. We can do it, but I can't comment on it.
On what
like
material?
Buckminster fullerenes or something. And what about the current that you're running through this thing? Is that going to, what kind of power supply are you using, and what kind of current?
Yeah, so it would be high voltage power supply, but it's not unusual to get voltage triplers that can get up to 16 kilovolts. This used to be, and it's fairly low current. It's 2 amps. So we're looking at still significant power. It's a couple of kilowatts power supply, so it wouldn't be unsubstantial. But we could start small with low voltage, and then slowly work our way up to the higher voltage devices. I would probably want to start with a lower voltage device, because the dielectric strength of this nanowire, I'm not super clear on how much dielectric strength we could get. Whether it would really bear 16 kilovolts or not. So that's something we would really drive us to high permittivity insulators on this material. And that's one of the reasons I hedged a little bit on the diameter of the material. If you notice, William can make a much tighter diameter material than what I took credit for in the paper, because I'm worried about dielectric strength, and we might need a much thicker insulator than what William is currently planning.
Awesome. Okay, well, thank you, Gary. Let me bring Yanis on. He had a question. Yanis, go for it, sir.
Thank you very much. Thanks for the presentation, for everyone being here. So my question actually is a very fundamental one, and maybe I want to ask actually something more in general. And I have sent 2 mails multiple mails to different people. I've been on a Arcturian ship, so on an alien ship, and I have other psychic phenomena print screened, which I could share, but no one seems to care. Maybe they think I'm crazy, or I don't know. And and it's interesting because the guy from the man that stare at goats, he was very keen on knowing more, and he responded in a very nice way, and I have great respect for this guy. And it seems to me that the intel agencies, first they do all of this.
Sorry, Yanis, to jump in. Which remote viewer did you approach on that? The men who stare at goats. That's a remote viewer, right?
Yes. Yes, I approached. Well, one of the 3 George Clooney's, and the one who has the manual written.
Oh. I'm trying to
you know
remember
which one, right?
Well, let me see. There was Ed
the
Dames, right? I think Ed Dames was maybe the
Ed
most.
Dames?
Then there was Ingo Swan.
No, not Ingo Swan. I don't care about Ingo Swan.
Was it Ed Dames you approached? Anyway, please continue with your story.
Yeah, he's very busy. He does the database, maybe. Yeah. So the thing is, I don't understand what are you guys missing, because the intel agencies, I don't trust actually I'm sharing so much information, but sometimes I think, am I stupid for doing this? Yeah, I mean, you laugh, but a lot of people die every day, you know, because of
Oh, sure.
conflicts. And it's not
Yes,
funny
yes.
to me, actually. It's very sad. And in a way, I would like to provide insight and help because I have some answers to some of your questions.
Okay.
But then I see a lot of reluctance and ignorance and a lot of pushback. And I don't understand. I mean, if you don't want to talk about it and just make some happy seminars, tell me, I will stop emailing you. But if you actually want to get to the bottom of some of these questions, I'm open here. And just give me a call or whatever. Write back, yes, please, have a conversation with me.
I'm open to any ideas. I actually think this is a very crude device. Probably this
Thank
isn't
you.
how UAPs are working in real life.
No.
I liken it to vacuum tubes. I don't know if anyone who's played with vacuum tubes, but I loved vacuum tubes as a kid because I like little miniature physics experiments under
Yes.
glass. And this is not how we make radios anymore, right? We make
The
radios with
dancing of the lines, I imagine. Yeah, it's fascinating.
yeah. So this to me is like the gravitational equivalent of a vacuum tube. It's a very crude device. It uses just raw physics. It's just clubs general relativity over the head. It's brute force.
Yes.
But really, how these craft are probably doing it with metamaterials, it's probably more like the raw emission of gravitons. I don't know if anyone's familiar with Giorgio Fontana, but he has predicted at S-wave, D-wave junction of two different style superconductors that you can get gravitons emitted out directly. And there's a Greek researcher who goes by Thanos, who is trying to do this in a lab setting. I've shared some of this with William. We're not sure he's being successful, but I think that's sort of the right track for the long term, you know, really making these devices super usable would be a graviton emitting diode. Someone needs to invent a gravity emitting diode.
You can influence those you know the old CRT monitors which we used to have, the big monitors like in
Yes,
the 90s, 2000s, yeah.
Yeah.
Those you can influence by projecting energy, like psychic energy into them, and they will flimmer. And you can do this over huge distances, and people will be very creeped out if you do. But it
I
works.
didn't used to believe this, but I've studied quantum entanglements, and I believe this.
I've done it. I can probably make some experiments with you guys.
Well,
yeah,
if I could interject for a
Works.
second,
Please.
Yanis, probably the best way is, do you have a website or some contact info?
No. I've written you an email. I could prepare a presentation, but I'm not willing to write 10 emails and get not even a no thank you. And I'm not on social media. I hate this bullshit, you know, of I'm this persona and this is my. You talk a lot about not principles, but you talked about this alien starship stuff. And then you do some securities, and I'm like, what is this? Like, what's the idea? You know, is it money? Is it status? Is it some fancy party? I don't understand. So
if you put your
yeah.
email into the chat, then we would have.
Yeah, I will do. Thank you.
Yeah. Okay. Well, thank you, Yanis. Thank you.
You're welcome. Thanks a lot.
Okay. So let me see. Let me go for other questions for Gary, and if anybody has any. Okay, and there's Yanis' email. I see that. If anybody wants to ask him, and again, he can share his experiences and where he's learned through those. And so if anybody else has questions.
I got a question.
Go for it, Michael.
So first, Gary wanted to talk about superlattices and fabricating superlattices. When I worked for Hughes back in the 90s, early 90s, I was working on making a new kind of infrared detector that used what's called a superlattice. Have you ever heard of that term before, superlattice?
I haven't heard of superlattice, no.
Okay, and the way we made it was with a process called, the acronym was MOCVD, and that stands for metal oxide chemical vapor deposition.
That I've heard of.
And what that would do is you'd put a single atomic layer at a time, and you build up a stack of layers And that's what the superlattice is. And it's essentially, it's a metamaterial. But now, my experience is that's with this kind of metamaterial, it has some unique characteristics. So you can make like what's called an optical switch, where you apply a bias to this thing and then the light turns off. And then you turn, and then when you try a bias the other direction, the light turns on. Or you could do it with the magnetic field, for example. So, and that's it, but it's an optical effect. And now, in some of those several of those equations you were going on, it appeared like what you were doing is you were taking the dielectric or the permittivity, high permittivity,
Yes.
to somehow affect the stress energy tensor. Okay. And so basically what you're doing is you're using something electromagnetism somehow to affect the protons or the mass, the matter. Okay. Now I've heard of materials where you can change the crystal lattice structure, for example. You can go from like a octahedral to a tetrahedral and back again. Essentially,
like a phase change, like a phase change.
You're changing the lattice structure, so the mass, the density is going to be different. Follow?
Yes.
But I've never heard of anything where it actually affected the weight of the material. Okay,
Yeah.
and that's what you're talking about when you're talking about.
It's not the weight. It's not affecting the weight. What is affecting is the coupling of the changing of the mass flow.
Right, but that's the mass flow of electrons, not protons, correct?
It's the mass flow of anything. It would change the coupling of the mass flow.
So so this is where my confusion, I'm feeling confused about how you take an optical phenomena and then make it into a
gravitational phenomena,
inertial phenomena. Okay,
right.
From electromagnetism to
I am just using Sarfatti's. Yeah, I get the question, and I can't really answer in a non-mathematical way because it's not obvious to me why an electromagnetic effect can appear in a gravitational regime.
Right, and so the other reason I'm asking is when we observe something like the TicTac in the infrared, we can actually see surrounding the TicTac stuff's going on in the space around it. Okay, this isn't something inside that we're seeing. We're seeing something outside.
Yeah, so some kind of field around it.
It's something different from this hypothesis of it has to do with this metamaterial, for example.
Yeah, and Michael, if I could jump in for a second, that's something, actually, that's a point that several other people have made as well. And I think there are a lot of unanswered questions there. Is the effect that Sarfatti has described from the emails that I've read on this, does that end at the ship's hull, the UAP hull, right? I think that was basically what they're saying.
And it looks like there's a field emitted externally to that hull, right?
Yeah.
So I get your point, Michael. I don't have a good answer for you. I don't.
Okay, thanks. So
it doesn't seem like
we don't know. This is how we find out.
Yep. Yeah.
Right?
Yeah.
It doesn't seem like enough to account for everything.
Awesome. Okay. Well, thank you, Michael. Well, so let me see if we have any more. Let me see if we have any more. Oh, there's Will. Sir, would you like to go again? And you have to unmute, Will. There you go.
Gary, I was in your at the beginning of your presentation, you said that the TicTac had no external surfaces. However, in the artist renderings that I've seen, the TicTacs always have two antenna-like features on the bottom.
Really?
That look like 1950 style antennas. Can you comment on that?
I hadn't spotted that, but one of the issues is there's so many different styles of these craft floating around. So it's really hard to speak in terms of generalities of just TicTacs, for instance.
Yeah, it's something I've seen on the news, so it's like,
Okay.
you know.
Yeah,
what-
we might get
what-
more answers
what's
at the end of
going on
June.
here.
I don't know.
So,
Yeah, I can't really, I'm not, that isn't, the only reason I presented like Hal stuff is to show the overlap of the UAP work and how much it overlaps with the gravity work.
mm,
And that I've been actually benefiting from some of their ideas too, like some of Sarfatti's ideas and I think hopefully it goes the other way where some of the high frequency gravity wave stuff has benefited them. I don't know if it has or not, but there's definitely some overlap. But I'm not an expert on UAPs, that's for sure.
Awesome. Okay. Well, Gary, thank you again. Will, thank you again. So I think we're all set for now for Gary. And let me go back to gallery view. Everyone, please give Gary Stephenson tremendous applause for tremendous presentations.